Hi, welcome to Physical Geography and Geological Research in Terschelling as part of the Field Course 2 Terschelling. This is an introduction to the physical landscape in Terschelling. My name is Sjoerd Kluiving. I'm one of your teachers in this course. And Philip Verhagen is also present. He will work you on the assignments in this course. This presentation will have two main parts. One part is looking at physical geography research methods. We're looking at Google Earth from elevation maps, AHN, geomorphological maps, soil maps, geological maps. In the second part, we will actually focus on the geological research methods. And we have an introduction to Dino Loquet as subsurface data, some corings. We look at subsurface models. And we look at deep models, deep subsurface models, and also at shallow subsurface models. And they will all help you in getting a better understanding of the physical landscape of Terschelling. Okay, so let's go to the next slide. So part one, more physical geographical research methods, a short introduction into these various sources. So let's get started with Google Earth. Google Earth gives a good handle on land use. Also the difference between polders, for example, and if they wood, heath, grassland, arable land, are there buildings, differences within the polders, especially between grassland, arable land, but also what relation they have with the content of the shallow subsurface. Is there a relation with land use and geology? Is there a relation in the transition, for example, between high and low parts, like the dunes, for example, or the beaches? Okay, so this is an example of this sort of nice contrast between the dune area and what we call arable land, grassland, and also a transition of high-low to dune polder. So let's take a closer look at those ones. So here we in number one, we're in the dune sand, high and low elevations. You can see that elevations can be measured as up high as almost 10 meters in the distance up to less than 3 meters in the foreground. So we have this sort of relief-like terrain, which is typical for the dune landscape in Terschelling. Then this is an idea of arable lands, probably some sand-clay alterations with variable elevations. You can see here this is the lowest part, 0.67 plus NEP. This is 1 meter plus NEP, and this A horizon is basically the slope. It says here it's 3.25, but it goes from 5 meters up here to almost 2 meters here in this part. So this is really a sloping part. You can also see how much that influences also the different land use. And another example is this grassland and the sand road next to it. You can see the sand road is slightly higher, probably due to elevation of the sand or maybe other causes, but this is just the observation you can make from Google Earth in land use. So finally, we look at the transition from high to low, and also look at basically at the land use change from a more wooded area here in this area to a more open landscape at the dune. And the elevations are about 6 meters at the top of the dune of the cycle path here, and a little bit more than 2 meters here in the foreground. Okay, then we go to the HAN viewer, or the digital elevation map of the Netherlands. And first of all, we need to select the HAN4 dynamic opmaak. Here you can see right here. And then we have to zoom in on the fieldwork area of Terschelling. Then you can see that Terschelling is clearly marked by high elevations and low elevations. And especially this dune margin, the inner dune, is very typical for this landscapes because they show the highest relief, maximum distance of the inner dune towards the land, and it's really a very typical thing you can see all along the Dutch and Belgian and also German and Danish coasts, where these inner land dunes have the highest relief because of the wind processes which shape them. And what you can do is with this digital elevation map is to click on the map to get you the elevation in meters NAP. This is the national ordnance data, basically the NAP, which we sort of national standard. And so that gives you on every part of the map, you can record these elevations. You can also look at it from a hillshade type of perspective, in which you see more contrast, more clearly the contrast also in, for example, the land use in here, but also the sharp relief transition you can see over here. One of the assignments will also explain at the end of this presentation is to draw a topographical profile. And you can do so here from A to H extent, and you can see here you can draw it actually on the HA viewer with the you can get a nice sort of image of your file. But what you can also do is you can select to export this in a table format. This is the profile export, and import as Excel data. And you can use this data basically to draw the profile on A0 paper. Paper will be provided for, and this is one of the first part of your assignments in this prep week, this indoor week of the Terschelling Field Course 2, to draw a topographical profile based on the data you get here from HAN. Okay, some other more special features of the digital elevation map are examples near Midsland, where you can see that the turp is located on a sort of higher elevation. We also see different parts, as you can see here in B, but also in part in D here, where we see also that parts of the sand beach ridges are basically also associated with the turps in here. And you can see very nicely that below the inner dune ridge, you can see these beach ridges also popping up and coming closer to the surface, and also revealing itself also as potential places for habitation in the past. Okay, so that was the part on the maps, or at least on the elevation maps and also Google Earth. And let's now go over to some more subsurface models as far as the geomorphological map and the soil map. And also later we'll see the geological map. So the geomorphological map, you just have to select it here from the geomorphological models. And we can actually look at the whole island from a geomorphological perspective. We'll go through step by step. We can see different units also making it up. Of course, by clicking on the map, we can actually see also what these geomorphological units are, what they are. So at first, the beach ridges, the strandwallen, which are quite clear. I pointed them out already in the digital elevation map. And you can see here that they're nicely present here in soft yellow tints. And this one over here, but also here and here. And we see over here these nice indications of a former, you could say, coastline, which constituted this beach ridge. I think one of the interesting questions also in this field course is also how old this coastline might be. To what archaeological period can we associate this older coastline indicated by the beach ridges? Then we have the coastal dunes with plains and shallows. We see basically the dunes on most of the seaward part of the island. This big blob of yellow is coastal dunes, but also, and that's quite interesting, is this higher dune part. You may remember from the paleogeographical lecture that there have been two islands in Terschelling in the history of formation of the island. Perhaps this sort of awkward shaped coastal dune complex is associated with that. So far it's a question. Then we see enclosed beach plain, which are spread out over the lower part of Terschelling, and we see all this in yellow, and these are real flat reliefs, the former beach plains, you can say. And this is a plain of tidal deposits, so clearly different from a beach, you can imagine, because it's more underwater deposited. And here we see some undulating tidal deposits, and these are tidal deposits which are offshore of the dike, and they are being in several places. You will have these, and they have slightly sloping relief caused by wave action and other tidal activity. To conclude, the geomorphological map also has the beach plane. You can see here outward the dikes. You can see even outward of the undulating beach plane over here. And then we'll get to the soil map. Again, select the BRO soil map in surface models, and you'll get an overview of the island in soils. So I'm not going into depth into soils, but it's good to have an overview of the variety of soils, because they can tell you also a lot about the substrate and also about the subsurface in which archaeological finds can be found. So the areno soils are silt poor and weak silty fine sand, and are the hydromorph wet type of areno soils, which show wet characteristics also in some of the soil properties. And they contrast with fluvisols, which are lime poor clay up here, and we have the histosol with organic upper soil on sand. These are more peaty type of soils. They're not peat in itself, but they have an organic component in them, which make them also different from other soils in the area. Then we have the areno soils, the arid, non-hydromorph version, also duinvaaggronden in Dutch, also silt poor and weak silty fine sand. You will see that when coring that a lot of these sand soils may look alike, but it's important to pay attention to the different properties which can assigned to either a hydromorph or non-hydromorph thing to sort of say something about the variety of these soils and associated sediments. Okay, to conclude the maps, this is the geological map of 2021, and you can see it's a very you could say generalized map. There are certainly older maps also which show more variety, and also older soil maps. But basically, it's these maps are sort of stratigraphical units, like coastal dune on beach deposits on tidal gully deposits, or tidal deposits locally covered by other tidal deposits, or a sandy beach deposit on tidal gully deposits. So you see that there's a different type of different type of environments in geology described, but you can also get it from DINALOCAT, and you can basically analyze your area with all this information also from this. Okay, that concludes part 1. Now let's get into part 2, geological research methods. This is basically the you could say the part which comes closer to also to more actual coring research, and also be easily to compared also to coring research in Terschelling. Because what we look here is basically the available data which are present, and to look at subsurface data also from a modeled perspective, looking at what do we have already in-house. Before we start coring somewhere, we'd like to know what the history is of geological research. And as we will find out, there has been a lot of research been going on, and we can also be happy that that in the digital age we have now a very fine database which we call DINALOCAT, which gives us a lot of detail and a lot of information also before we start researching a certain area. This is exactly what the assignment I want to give to you, students, to look at the look at the available data and prepare yourself also on this landscape of Terschelling before you start coring into there, to look at the subsurface data, the corings there are, and also what the models tell you in there. And then we distinguish between deep models and shallow models. Okay, so at first, when you get into DINALOCAT, you have this choice between subsurface data and subsurface models. The first thing to do is you can look at further information and models, but one thing to maybe to highlight here when you exploring it is go to the stratigraphic nomenclature. And stratigraphic is completely renewed, and they you can actually search in the stratigraphic nomenclature on the subsurface model. You can look at a hierarchical way of organizing of stratigraphic units. You can look at age notation of it. You can look at stratigraphic groups. You can look by depositional setting, and you can look via diagrams. There are all kinds of ways how these different stratigraphic units are organized, and you can click on one of them, and they all give extensive information on Dutch shallow subsurface. These formations, which we'll call mainly the Naaldwijk formation, which is the most prevalent formation we will core for 99% of the cores or 90% of the cores. But there's a good link also further on in the presentation to look at the Naaldwijk formation, and I think it's good preparation also for Terschelling to read the Naaldwijk formation, and perhaps also a small hint related towards your exam at the end of this course. So most likely your question will be going about the Naaldwijk formation. Okay, so where is this Naaldwijk formation? This overview of geological formations in relation to the Dutch shallow subsurface. This is the Naaldwijk formation is over the Holocene. Formations descriptions that are relevant for this field course are the Naaldwijk formation and to a lesser extent the Nieuwkoop formation. In cases we do find peat deposits, and last year we found little signs of this peat deposits, we could assign them to the Nieuwkoop formation. But I think most of the units we have are from marine deposits. Naaldwijk formation is the origin of the not fluvial, also not glacial, and only from organic parts. So then the next step is to go to click the subsurface data, and this part here to get information about sediment cores. Later we will move on to surface models, but first let's focus on the actual data which are present in the DINO-loket. So what are the data all these models are built on? What are the data that can give us more information about the past? Alright, so again you go to subsurface data, then you have to select the bodem- en grondonderzoek, or the soil research knob, and also zoom in on the fieldwork area in Terschelling. Then it's in part, we see now part of the fieldwork area, and then you have to select only geological cores, that these are the ones to do, and you have to deselect, make sure you deselect all the other cores, otherwise it becomes quite chaotic and you may get too much information. So for now we'll focus on the geologisch booronderzoek. Okay, so here are the drill tracks for this season of the field course. You can see that there are 6 cores which are sort of parallel on the island, 1, 2, 3, 4, 5, and 6, and there's one longitudinal one, number 7. At first we'll focus on these traverse groups, and also we'll make a so we'll see how much time then stays in for that. Okay, let's go further into this one. So again, you can see also the amount of cores is quite extensive, or quite nice, has a nice coverage on the island. So when you select a drill track, this drill track number 3, make sure you select at least 12 cores along a drill track. You can see this drill track 3 has many more cores, because actually the drill track is also in a nice line, as you can see over here as well. So again, make sure you select those cores, and also make sure these cores are located on the track or quite nearby. So first an example of the subsurface data if you were to select one core, and then next I will show you to select how to select the cores of the entire profile you need to research. So you'll zoom in on, click on the core, like for example this B01C0099, and then a screen pops up with the basal data of the core, and you can even get a profile also from the core, but you can also click on the data CSV and download core information in table format. So this is the way how the profile looks like, the basal reference of the data, and you can actually see what the core looks like. So it's a nice representation, but you can also download the core profile to draw your own core. So when you have such a core presentation, you can make all these different you have all this base data. The core sample of the profile gives some information on the lithostratigraphy and the lithology. And the lithostratigraphy is here on the right, and the lithology is on the left, and the lithology is on the right. And it sees there's a nice alteration of biedt, and we see here the Naaldwijk formation and the Nieuwkoop formation. And you see the upper one is also Naaldwijk, but then schoolpakket. And this is the Nieuwkoop formation. This is the Naaldwijk formation marine part. And we have here a lithostratigraphy, a subdivision information, and also the lithology, which gives the characterization of sediment composition. So between peat, clay, and sand, middle category, and sand main category. So it's good to realize that within sediment core subsurface data, we have the same sort of distinction in sediments we can also make in the cores between sand, silt, and clay. Okay, so like I told you, you can also select a larger quantity of cores, and it's by this way. So again, you're still in the bodem- en grondonderzoek mode of the DINOLOCAT map. And you can actually, by clicking this icon, you can actually draw a rectangle around desired cores. And then if you finish those selected, when you finish this drawing is selected, you will automatically go to fill in some requested information. So you can actually request those information from the system and get all the information at once in one file. How to do this? You basically, after you click, you come to this screen where you select objects to download. So we have about 14 cores downloaded here, so that's more than 10 we said, or more than 12. And then we go to the next slide. So we add it, and we also request the download. And then you nicely fill in your names, your affiliation, your email address, and also it helps to put in when you do multiple requests to put a number in there. So I put in Terschelling 1, and then next, you get a confirmation that you got this download is served, and it tells you that you get an instruction with instruction. You get an email with instructions when it was confirmed. And although they tell you it lasts up to 4 hours, I got mine within the minute. So here's number 2, and this is the confirmation. And you actually have a download button in your mail message, in which you go to number 3, where you have different type of zip file, contains a text file, but also on sedimentological description, also KML files to open in Google Earth, the location of the cores, and you have chemical and grain size analysis. And then if you go to open up, for example, the first one, you can find all the grain size or the lithological descriptions of each core in here. And these are the 14 core descriptions in this file to be extracted at once. And that's the way how it goes with DINOLOCAT subsurface data requests. So when you have such a coring script, this sort of you will have the general data of the coring. And you also have the depth, sort of the name of the core, and also the locations, the XY of the core. The depth data of designated layers, the upper part and lower part of a layer. The color, the main grain size, the median grain size of sand fraction, the sand median. The clay, lutum, silt and sand percentages. And also organic material and also calcareous content. These are all, you could say, the fingerprints of sediments. Important also to look at these funds also from a perspective of joining certain horizons also with each other when they have similar type of characteristics. So this lower part, they look like the same, but you have to look at the difference between them. So how you can sort of generalize profiles. The details reduce the details to mappable layers, layer packages and formations. That's important also to using it when you are going to introduce these corings into your profile. Okay, so that was the you could say the part on subsurface data. So let's now move to subsurface models. So it clicks subsurface models, and it models the structure of the Dutch subsurface, and it's based on sediment cores and sediment data. And it's an important part of DINALOCAT, in which basically models the subsurface based on the available data. Let's first look on the DGM part. The DGM part is a model structure of the shallow and deep subsurface area, and it's area-wide in the entire Netherlands coverage. So you can see everywhere, but you can see that the concentration or the density of these cores is, well, just estimated. I can see about maybe 15 to 20 cores on the island, and of course most of the cores are within the Wadden Sea. And some of these cores, as we will find out later, can be hundreds of meters of deep. So they were also used for different reasons than archaeology or quaternary stratigraphy. They were also used for, a lot was used for the fossil fuel industry, of course, in the area. Okay, so we select one core, this is BO1 CO166 of the BRO DGM1, and then we have a large core. It's about 60 meters, and a depth interval to, you can adapt it to like the current level of AAP. We study only the shallow subsurface from ground level to a maximum of 9 tenths meter NAP. In each of these subsurface models, you can have the geological units, the stratigraphical with Holocene units. That's not summarized, and we have the lithology, so loam and very different type of lithologies in there. They're also modeled, and they come closest to this area. Also, again, still in this sort of deep database, we can actually draw a profile also on the area, and the profile here's the profile, and we can see the how we have basically a large part of the upper part is the Holocene unit, which is basically Terschelling. I think about the paleogeographical reconstruction of the island. This is a thick unit of almost more than 30 meters, and below that are older quaternary stratigraphic units like the Palo Formation, but also the Eemian is in here. This is the pre-last interglacial, and they're also on the basis of Terschelling Holocene unit. So interestingly for deeper geologists, but it's a you can say this is a sort of overall view of the subsurface models. Okay, then let's shift over to the GeoTop V1.6 models. That models the structure of the shallow subsurface, and that covers the entire Western Netherlands. So we're happy to to include Terschelling as the Western Netherlands, but the rest of the Netherlands is experimental. But you can already see that the good or the advantage of the geotop model is that it has a quite high density, of course, in the area using it, and also making, as you will see also later, to be used direct use of cross-section, but also synthetic use of the area in between the modeled area, and the reliability of the model is quite high in this area. Okay, so first, when we click a model, we have this depth interval. We can adjust the same depth interval. You can basically show how your core will look like, and I would propose we'll limit ourselves to a maximum depth of 10 meters, because that's where the upper part of the Holocene part is, which is relevant. I would say starts to become relevant for archaeological data. Again, in this this area, we have the sort of legend also for geological units, and a lithology, which gives a more general sediment composition. The geological units, of course, are listed in formations. So within DinoLoket, we can basically also click on this part in here to record a profile. We can select a transect line in here, and then when we selected it, we basically have we can change it. We can basically delete the line and get a new line if you're not happy with it, for example. And when you're happy with it, you can show transect, click that part, and then we'll have you could say a subsurface model for the elevation model here between -50 and +14 relative. So that is we can see some similarities to what we've seen in the DGM model, but it looks already a bit more detailed. So let's now change the elevation interval to something more suitable. So this is between -14 and +14 as being that, and now we have you can see a longitudinal east-west cross section, and we can see the schorl deposits. You could say probably the beach ridges on top in this profile, and some of the anthropogenic elevations, maybe the terps in here. We have to look for that. It looks like, and we see also a nice sort of alteration. We can the other thing we can do here in this map, we can look at of course, is the formation of Naaldwijk. This is the main geological formation in the area, and we can look at the map. We can look at the thickness. We can also at the thickness depth, the top of the thickness, and also the basis of the thickness. So you can get all kinds of maps in there. And to illustrate it to you, in the next slide, we will see a map of thickness. And this is the one. So the example shows the thickness of the formation of Naaldwijk in the area, and it looks quite the same basically for the thickness. Only for south of Hay we have this sort of yellow part, and interestingly this is sort of a thinner part. We should track a profile in here to find out, but it looks like that there's a thinner part of Naaldwijk formation, and perhaps something of the shape of the island has to do with the thinner part of the morphology of the island. The curvature of the dike here might be related towards the thinner position of the Naaldwijk formation. Okay, there is already talked about the real cores, and we're going to now talk about the synthetic cores or the modeled cores. These are also called the appelboor. And the apple bore, you can click on, first one you clicked of course this node on the right one. You can basically click on any site in the modeled subsurface, so you do not necessarily need to click on a core site. No, you can basically click on any site in between the cores, everywhere, to generate a apple bore. And this is what it looks like. And you basically can create an apple bore on every selected site at Terschelling. And you can see here we have such a apple bore of 10 meters. It gives you, of course, the geological units in there, which is quite the same. But much more interesting is this lithology in here, which shows a variation on most probable, but also the highest chance on the lithological unit you have. And the variation in here shows some sort of dynamic behavior of the sediment, which fits if we look at the paleogeographical record. And that makes it really, I think, useful also to use also in our research to create our maps, to look at this sort of dynamic history of the island. Okay, so we've come to the first part. We've sort of recap. We've come to the end of this presentation. So we have looked at the paleogeography of Terschelling. We looked at the physical geography and geological research in Terschelling. We looked at the physical geographical research methods, Google Earth, the digital elevation map, and the geomorphological map, and also the soil map, and in the end also the geological map. Then in part 2 we looked at geological research methods, Dino Loquet, and we basically looked at the Naaldwijk formation basically in subsurface data and in subsurface models. Subsurface data, we've also reviewed how we can order those data. Just by selecting rectangles we can order them by email and get a whole part also to analyze on any part we wish to analyze in Terschelling. And with the subsurface models, we've looked at the deeper models, the DGM models, and also to look at how these models have a sort of coarser structure, give some coarse information on the Holocene formations in the area. And then if we look at the Geotop V1.6 model, we see that we can look at much more, on one hand, more information also of the area. We looked at the modeled information, which gives us more information on the alteration of lithologies, maybe more clay versus sand alterations, and we see that the modeling has a high reliability also in the area. So we can, with reference of course to the database, we can for a certain degree be certain that it's might be close to the truth, what we see in those models. But there's I think you can have an interesting discussion also with Philip on these results. But these basically are also part of your assignment for in this course. And now we'll come to the assignment, which will be done in question groups of 2. That is first, like also was being addressed also in the first part of the lecture on the introduction on the topographical profile, which you can get from the digital elevation model. And you can basically, along one of the sections, and I would choose 1 to 6, look at slide 35. Slides might be quite different in here. Look at slides 13, 14 for instructions. Use appropriate scales, vertical and horizontal, and I would certainly consult Philip also in this request also to discuss your choice for vertical and horizontal scale. And I also stress that I think you come to an agreement which might be the most suitable scaling. So that's first, and then take also into consideration adequate space to draw question 2. The steps in slides 13 and 14, they allow for the downloading of the tables with the elevation data, and you have to copy those data into the elevation profile to generate your own topographic profile. That's 1. Okay, so then if you have done 1, we'll get to number 2, which is generate a geological cross-section based on the subsurface data and information in slides 40 to 44. Draw on the same paper and insert underneath the topographical profile you generated in 1. So make sure you have enough room in your profile to generate this geological layering underneath your topographic profile. Okay, then that's quite it's quite some work to be done. But then, if you've done 1 and 2, you can redo the cross section on precisely the same transect, one of the first one of steps 1 and 2, but now with subsurface model. And then I would not use the DGM, but I would use the geotop V1 and consult slides 48 and further, and take into the same vertical scale as in 2. So then you have a good way of comparing. But first make it, I would say, with your own hands, with the cores, and then compare it with the geotop model. Okay, so that's a lot of, you would say, introduction into the soil, also into the layers, into the different units also being present. And then after 1, 2, and 3, I want you to answer the following questions. What are the main differences between the two cross sections? And B, how does a core of geological data compare with a appelboor, which is such a synthetic core? So give some insights into that. And which of the two cross sections can be most valuable for archaeological research in Terschelling? So either the geotop profile or the geodata profile. And what other sources, you either from Google Earth or digital elevation map or different map types, can support or refute the findings of questions A, B, and C. So what sort of support or maybe neutrality you can look at the maps. Okay, so when there's time left, and I doubt it will, but perhaps some of you will, you can also apply the same assignment, but then on section 7, we're on slide 35, which actually goes a much which is much more extensive on the island, and which also gives another view of the soil. Okay, good luck with the assignment, and I will surely see you in the field.